Let's work through an example of a chi-square analysis testing the relationship between two categorical variables. These are real data, and we'll see how they were published and written up. And it's a survey of eating habits of adolescents. And in this cross-sectional study, researchers asked, are you a vegetarian? And have you ever had an episode of binge eating? We always start with, what is the research question? Is there a relationship between being a vegetarian and ever having had an episode of binge eating? And then we think about, how many variables do we have? 2. And what types of variables are they? Well, one variable is vegetarian. There's a lot of different types of vegetarians. We can define that variable in so many ways. We talked about the very first week in this class. So you have to ask, how did these researchers conceptualize that variable? Are you a vegetarian? They said yes or no. That's it. And this is self-defined. So some people might consider, if you eat honey, you're not a vegetarian. It's a very strict definition of a vegan. Some people say, I'm a vegetarian, but I eat chicken. Mary Tyler Moore said, I don't eat anything that has a face. So there's lots of different definitions of this. What's important is that these data are binary. Then we have this other variable. Have you ever had an episode of binge eating? Now, I'm a really big proponent of person-first language when it comes to health issues. And so instead of saying diabetics, I make an effort. I'm not perfect, but I make an effort to say people with diabetes. However, just for the ease of talking about this, I am going to use the word binge eaters instead of saying every time ever had an episode of binge eating. So I'm going to say vegetarian and binge eating, or binge eaters. So if we look at the data, this also is conceptualized as a binary variable. How do you define binge eating? I definitely binge eat. This is a picture of Trader Joe's speculoos cookie butter, which is I have basically at my arm's length every time. This definition is really important. I saw the definition of binge drinking as having 3 or more drinks in one sitting. That's not binge drinking, that's called dinner. But you have to think about, what data do I have? And here we have 2 binary variables. And these are the observed counts. These are the kids, the adolescents who answered the question. You counted up, I had 143 people who said, I am not a vegetarian and I've never had an episode of binge eating. We can take this contingency table and say, is there a relationship between these 2 variables? And we have to think, we have to be careful about causality and directionality here. This is a cross-sectional study. I just took a bunch of people and asked them questions. You can make some assumptions. What causes what, right? Does being a vegetarian relate to binge eating? If you're a vegetarian, you might be hungry. You might be more apt to buy stuff like Doritos. Doritos lead to binge eating. Or maybe it's the flip side. If you've had a lot of episodes of binge eating, such as all you can eat crab legs or all you can eat wings, you're like, I'm done. That's enough for me. I'm done with that. I'm going vegetarian. I got to clean up. The directionality in here, we don't know in the cross-sectional study, but we can still ask, is there a relationship between these 2 things? First, we need to take our 2x2 table and we need to calculate the expected count. The expected count. So I'm going to go back and we're going to populate that table. No veg and veg, no binge and binge. So 143, 67, no veg, no binge. Right? And the other 2 numbers, I just got to double check, 58 and 46. So that's our 2x2 table. Then from that table, we can calculate the row and the column totals. So 143 plus 167 is, here we go, 210, 104. We have 210 non-vegetarians, right? 210 non-vegetarians. We can also calculate the column totals, 201 and 113. 201, and 113. And then we can calculate the grand total here, which is 314. So from our 2x2 table, we can calculate all of these numbers. Now, what we need to say is, if there were no association between vegetarianism and binge eating, what would we expect to see? Expect to see. To get the expected thing, see this number here, 143? That's actually what we observed. But what we would expect to see is row total times column total divided by grand total. That's this. And the expected for that is 134.4. In the next cell, the expected is this, this, and this. I'm not going to bore you with all the calculation, but we can calculate an expected count for each cell. Pause and rewatch that if that doesn't make sense to you. Now, from each cell, we can now calculate the chi-square statistic. There's a little typo on this thing right here. It should have this. Only one sigma. We sum up what did we actually see compared to what we expected to see, square them, and divide by what we expected to see. So in this cell right here, we would expect to see 134.3. What we actually saw was 143. So that goes here. Observed minus expected squared divided by expected, and we get this little number, 0.56. Again, Stata will always do this for you, but I think it's worth seeing the mechanics behind this. We're going to add this up for each of these four cells. This cell is going to be 0.56. This cell is going to add 0.97. Remember, what do we need to get up to in order to say there's a statistically significant relationship? We need to get up to a chi-square of 3.84. I never memorized that. I'm a dork. I'm not that much of a dork. I have other hobbies. But if I add these things up, we'll see it's going to be bigger than 3.84. I take that number, which is 4.60. Oh, I lost my pen, which is 4.60. And then I want to see what's the probability of getting 4.60 if the null hypothesis is true. So I'm going to draw out what I would expect to see if there was nothing going on. I said I would expect to see something around 0. Sometimes just by chance alone, I'd get something a little higher. That's sort of what it looks like if the null is true. 4.6 is like somewhere over here. And the area to the right of that is P equals 0.32. The probability of observing a test statistic of a given magnitude or larger if the null is true. Reject it, and there is a significant relationship. Something is going on. We're going to see how to summarize that relationship in the next set of slides.